Hi guys, this is part 2 of the mean and standard deviation lesson. So if you haven't watched part 1, I just split it into 2 so that I didn't waste time if it wasn't actually working. So go back and watch part 1 if you haven't, but we'll just continue on from here. So this is at the bottom, it says page 12 if you're not with us. So the mean and standard deviation. So this is just applying some of that stuff that we learned on the other page about what standard deviation is and how it's represented. So we have our group of 17 friends from last day that were ranking fries. And now, so whatever we called restaurant A, did we call restaurant A McDonald's? I don't remember. But now they have a second restaurant, so restaurant B, that they're ranking. So they've completed their first survey, now they're eating some more fries, and this is how they ranked the second set of fries. So it says, these were the rankings from the other day. We practiced putting that in, getting the overall mean using those two methods. Method 1 using raw data, and method 2 using the frequency table. So make sure you know how to do those. So it says how many people took part in the second survey. So we would add up 1 plus 3 plus 4 plus 6 plus 2 plus 1. And that gets us 17 again. 17 people, so they didn't lose a friend or gain a new friend unless they replaced somebody. But it's that same number of people. So it says, what differences do you notice about the two sets of data? So if we were comparing restaurant A to restaurant B, we could do our statistical analysis for restaurant A and restaurant B and get some information about how they're different. But just looking to start, I see that when we did restaurant A, there were some people that really didn't like the fries, so they gave it a 2, and there were some people that really liked the fries and gave it a 9. Whereas at restaurant B, we don't actually have that set of rankings, so nobody gave it a 2 and nobody gave it a 9. And we see that at 6, we have even more people kind of close to where we think that average of that mean would be. We have even more people. So we have fewer people giving higher and lower ratings. So the data is less spread out. And so it says, sorry, I'll let you write that down if you're writing. So now we want to do some of that analysis. So we did restaurant A the other day. You can do it again, or you can flip back those couple of pages to get information on the mean, median, mode, minimum, maximum range, and standard deviation. I guess we hadn't written down the standard deviation. So just practice doing those keystrokes for restaurant A and restaurant B. So again, you can do the method 1 from last class. And so that's using the raw data. So sorry, I should say method 1. For restaurant B, what your raw data would be 3 and 3/4, then 4 5s, then 6 6s, then 2 7s, and then 1 8, 4 8, 11, 14, 17. Okay, so that's your raw data. That's what you would do for method 1, where you're just putting it into list 1, or you can do the method 2. And again, that's the frequency tables. So that's using L1 and L2. And think about the little changes that you need to make so that it's calculating from that. So try both restaurant A and B. You need to do them one at a time. So do restaurant A, figure out your mean, median, mode, the minimum value, the maximum value, your range, and then look for your standard deviation as well. And then do the same thing for restaurant B. So please pause it, do each of those, and then I will do it, and you can make sure you did it all right. So hopefully you've done it. So the mean for restaurant A, when you punch it all in, is 5.52. For restaurant B, it was 5.47. So pretty close means. About 5.5 is the average rating. This one's a little bit higher than for restaurant B. The median, the middle value, so again, if you lined it all up and looked for the middle value, it was a 6 for both. I believe once you do your single variable stats, it tells you that as well. The mode, so what's seen the most frequently, just looking at the frequency tables, the value of 6 was given the most. The minimum for restaurant A was a 2, for restaurant B was a 3. The maximum for restaurant A was a 9, the maximum for restaurant B was an 8. So the range is maximum subtract minimum, so the range was 7. And for restaurant B, the range is 5. So for the standard deviation of each of these, so you needed to find that after doing either of these two methods. Standard deviation is 1.684. And for this one, 1.242. And again, you should get the same thing depending on which method you used. If you're really having a problem getting these in, please send me a message and we can talk online about what might be going wrong. If it's giving you weird errors, please let me know ASAP so that we can sort it out instead of just hoping it goes away. We got to sort it out. Okay, so we've already, this is just saying do the same thing for restaurant B. So, oh, I feel like I'm missing a page. Oh, it says graph the histogram by hand on the graph below. So this one we would have got yesterday. So again, this is frequency, or basically how many people gave it that rating. So for restaurant A, one person gave it a 2. One person gave it a 3. 2 people gave it a 4. 4 people gave it a 5. 5 people gave it a 6. And then back down. So 2 people gave it a 7. And 1 person gave it both an 8 and a 9. If I were to draw it out for restaurant B, same thing. So 1 person gave it a 3. 3 people gave it a 4, and so on. So we could graph that histogram out. And what you can observe based on these two charts is this data is, or this graph, this histogram, is more spread out, whereas this is grouped closer together. So these are a little bit tighter together. Again, your range is smaller versus your range here. So that's what those histograms would look like for restaurant A and restaurant B. And gathering all this data together, this is what we did on the front page. So figuring out, again, Casio, your screens look slightly different, but have all the same information, I believe in the same order. So again, restaurant A, if you did your single variable stats properly, this gives us our standard deviation right here, just if you couldn't see it. This is your mean. If you scroll down, so it shows you your minimum, your median, and your maximum here. The mode you kind of had to figure out on your own. I think in the Casio it might give you your mode as well. And restaurant B again, mean, standard deviation, your minimum, your median, and your maximum. And again, just making sure that you entered 17 data points for both of those, right? So that's what we counted out. And so there's a little chart below. Oh, it shows us our histogram. And then this chart is basically what we had on the front. Ooh, what am I writing? Front part of this. That we had our mean, median, mode, range. So the mean being the same. I think I had given it 2 decimal places, 5.52 and 5.47, and I had given a couple more decimal places for standard deviation, so these are just rounded. So it says, what do you notice about the mean, median, and mode? So again, these are our measures of central tendency that we talked about last time, of the rankings for each restaurant. So if we compare for this chart, so the one that'll be right, oh, no, I went the wrong direction. If we compare for this chart that's right above this question on your sheet, mean, median, and mode are all the same, right? 5.5 for both A and B, 6 for the median, and 6 for the mode is the same for A and B. So we notice that they're So the next part says the range is a measure of dispersion and describes how the data is spread out. So use the range values in the histograms to explain which set of data is more spread out. And so again, restaurant A, if you look on it, has a higher range, and the histogram, that's that bar graph there, looks more spread out. And compared to each other, does the data, which is more spread out, have a higher or lower standard deviation? We've already talked about this in the beginning of the lesson, so we know that. But just to reiterate, data that is more spread out so in this case, our restaurant A has a higher standard deviation. So again, the higher the standard deviation, the more spread out the data actually is. All right, a couple more slides. We're getting close. So again, we've already talked about this, but just to see it again, because this is super important to understand. Standard deviation is a measure of how a set of data is spread around the mean. So a higher standard deviation indicates that the data is more spread out, whereas lower is less spread out from the means or more clustered around the mean. So for our two restaurants, restaurant A and B, again, standard deviation is more spread out for restaurant A and a little more clustered for restaurant B. So our mean, they're using mu here. I'm going to just change that to X bar just because that's how our calculators tell us it. So the mean was 5.5 for each of them, right? We said the mean was the same. So the mean is kind of in between here. So it says adding the bars directly to the left and the right of the mean. So that's these two bars. So 5.5 is right here because this is the bar for 5 and this is the bar for 6. Again, this is the bar for 5 and this is the bar for 6. So if we add to the left and the right of the mean, that's 4 plus 5 is equal to 9. So there are 9 rankings within one bar of the mean. Whereas within this one, so 1 to the left, 1 bar to the right, there are 10 rankings within one bar of the mean. Again, that mean, oops. So I don't know if always in this statistic booklet they put the mean as that fancy U there. It's called mu. Let me scroll. But again, we'll use X bar over top typically. So it says now add the next 2 bars out. Or sorry, now add as 2 bars out from the mean. So now instead, let me do a different color. Instead of just 1 bar, we're going to add 2 bars out from the mean. this one, 2 bars out from the mean. So for restaurant A, so we had those 9 already from here. And then we have 2 here and 2 here. So in total, there were 13 rankings within 2 bars of the mean. Whereas this one, so we had 10 from these two. Looks like we have a 3 here and a 2 there. So that 10 originally, and then if we add one more set of bars to the left or the right, now we have 15 rankings within 2 bars of the mean. It doesn't let me scroll with one hand. There we go. And adding the next bars out from the mean. Let's go green. So now if we're going 3 bars from the mean and 3 bars from the mean, so for restaurant A, there are 15 rankings within 3 bars of the mean because we're adding 1 on each side to that, or 13 from the previous. And for this one, again, we had 15 and we're adding 1 on each side. So in this case, all 17 rankings are within 3 bars of the mean. This we had 15 of the 17, so if we went 1 more bar out, I think we would have got everything. So our kind of general conclusions from these observations. So for restaurant A, less of the data is close to the middle, so it's more spread out. It has a higher standard deviation, so our standard deviation of 1.7 is higher than for restaurant B. So with restaurant B, more of the data is close to the middle, therefore less spread out. So it has our lower standard deviation. So let's put some stars all around that, because that's important to understand and to be able to identify. Oh, I see here in your books, I don't know if I copied this one out. It says, note, the calculator uses X bar to indicate the mean of a set of data. More common is the symbol. So again, it's like a fancy U. It's mu. If you see that, it's the same thing. That's X bar. So another set of data. So again, the other day we did, I think we probably did this classroom, a homeroom average height. We're adding in another class. So it's use the mean, height, and standard deviation of each class to compare the heights of the students. So follow the steps in the last lesson. So again, in this case, we can really only use the method 1, working with the raw data, but you need to do room A first, figure out your mean and standard deviation, and then do room B, and again figure out your mean and standard deviation. So try that now with these 2 data sets, again doing them separately, and then calculating it out, and then we'll answer these questions together after. So hopefully you've done that now. Again, pause it if you didn't. So use the mean, height, and standard deviation of each class to compare the heights of the students. So we're doing room A first. You've probably already done that. So the mean of room A was 167.5 centimeters. And the standard deviation was 15.559 centimeters. You might have rounded that a little bit differently, and that's fine. For room B data, the mean was 167.5, so it had the same overall average, but the standard deviation for this one was 2.813. Oh, and then we get ourselves a little fancy chart there, just to write it, you know, a few more times. So we can see that our means were the same for room A and room B, but we had different standard deviations. So take a second and think about what a high standard deviation means versus the low standard deviation. So the conclusion that we can draw is the students in both home rooms have the same average a mean height of about 168 centimeters or 167.5 centimeters. However, the standard deviation of the heights in room A is 15.6 centimeters and room B is 2.8. You can have the rest of the decimals if you want. Therefore, the heights of the student in room blank are more spread out. So we know that more spread out is with a higher standard deviation. So that would be room A is more spread out than the heights of the students in room B. And so if you kind of look at those data points now, so just looking at room A versus room B, so it's super easy to put it into your calculator and get this value and this value. But we could also look at the data. So looking at room A, it looks like the shortest person is about 140 centimeters, if I'm looking right, and the tallest is 194 centimeters. Hopefully I didn't miss any short or tall people. Whereas with room B, the shortest is 163 centimeters, and the tallest is 171, I believe. Oh, 172. If I missed one here or there, oh well. But you can see that these guys are probably pretty close in height, right? Less than 10 centimeters different, whereas we've got more than 50 centimeters difference from your shortest individual to your highest here. So this is much more spread out. So, my darlings, on the bottom of page 16 there, it says practice question 1, and then on to pages 17, 18, and that's the end of the practice in here. Absolutely do the questions in this workbook, so all the way up to page 18. I realized I didn't give everybody the key. I will send you guys the key to my book so you can look over your answers versus my answers for those. But make sure you do them because a couple of these questions continue on in the next lesson. So you need to be well aware of what kind of this scenario is, especially with that MP3 player situation. So make sure you've done those questions. And again, this unit is all about practice. So textbook work is super helpful for you as well to make sure you know how to put it in your calculator and know how to analyze it from there. So thank you guys. There will be a lesson tomorrow or the next lesson on YouTube, depending on when I video it, on normal distributions. So that's for tomorrow, but make sure you're done all the work for today.